Hello students, this is Kashima Soni and today we are going to take up our next topic, that is crystal field splitting in octahedral complexes. So far we have discussed the postulates of crystal field theory and now we are going to take up the next topic, that is another important topic, crystal field splitting in octahedral complexes. सो बिफोर प्रोसीडिंग मैं आपको बताना चाहती हूँ यहाँ पे कि जितने भी आपकी यूनिवर्सिटीज़ हैं मोस्ट ऑफ द टाइम ऐसे बीएससी के स्टूडेंट्स को ये क्वेश्चन पूछ लिया जाता है आपके सब्जेक्टिव पेपर में, दैट एक्सप्लेन इन डिटेल योर सीएफएससी इन ऑक्टाहेड्रल कॉम्प्लेक्सेस और टेट्राहेड्रल कॉम्प्लेक्सेस और डिटेल एक्सप्लेन इन डिटेल सीएफएससी इन वेरियस D1 D2 D3 सिस्टम्स इन ऑक्टाहेड्रल कॉम्प्लेक्सेस. तो इस तरह के क्वेश्चंस आपको यूजुअली पूछ लिए जाते हैं जो हम डिस्कस करेंगे यहाँ पे डिटेल में. ओके, so let's take up our crystal field splitting in octahedral complexes. तो मैंने आपको सबसे पहले ये चीज पहले ही बता दी थी कि जो आपके मेटल हैं और लिगेंड हैं उनको क्या कंसीडर करते हैं हम यहाँ पे एज अ पॉइंट चार्जेस. ठीक है, अब होगा क्या यहाँ पे, सपोज लेट मी टेक अप अनदर कलर. ओके, सपोज यहाँ पे क्या हो रहा है, ये मान लो आपका है एक्स जेड एक्सिस. ओके, दिस वन इज योर supposingly y axis and this is your x axis. ठीक है, अब होगा क्या, मैंने आपको क्या कहा था यहाँ पे, सी देखो अब यहाँ पे हमने क्या डिस्कस किया था कि जो भी आपका लिगेंड है इट विल डोनेट द इलेक्ट्रॉन टू योर मेटल. अब लेकिन होगा क्या कि मेटल की ऑलरेडी कोई इलेक्ट्रॉन डेंसिटी होगी, सी ऑलरेडी एग्जिस्टिंग इलेक्ट्रॉन डेंसिटी जो होगी मेटल की वो क्या करेगा, इट विल रिपेल द इलेक्ट्रॉन इनकमिंग इलेक्ट्रॉन्स कमिंग फ्रॉम योर लिगेंड. ओके, रिपल्शन होगी. तो अब होगा क्या यहाँ पे, अगर आपके जो मेटल के ऑर्बिटल्स हैं दे आर लाइंग इन द डायरेक्शन ऑफ योर इनकमिंग लिगेंड्स, तो उस केस में रिपल्शन ज्यादा होगी, अल्टीमेटली स्प्लिटिंग ज्यादा होगी. क्या बोला मैंने, एक बार फिर से सुन लीजिए इसे ध्यान से, कि जब आपके मेटल्स के जो ऑर्बिटल हैं, द ऑर्बिटल्स ऑफ योर मेटल एटम, सेंट्रल मेटल एटम, इफ दे आर लाइंग इन द डायरेक्शन ऑफ योर इनकमिंग लिगेंड, तो जो आपके ऑलरेडी इलेक्ट्रॉन डेंसिटी है आपके मेटल में वो रिपेल करेगी, रिपल्शन होगी उसकी लिगेंड्स, इनकमिंग लिगेंड्स के इलेक्ट्रॉन्स के साथ. ठीक है, विच इज वाई आपकी जो एनर्जी है वो इंक्रीज कर जाएगी, ग्रेटर रिपल्शन विल रिजल्ट इन ग्रेटर एनर्जी एंड अल्टीमेटली आपकी स्प्लिटिंग ज्यादा होगी, विच इज व्हाट वी आर गोइंग टू डिस्कस ओवर हियर. तो ये मान लो आपका ऑक्टाहेड्रल स्ट्रक्चर है, इट इज एक्चुअली ऑक्टाहेड्रल स्ट्रक्चर. तो आपका जो जेड एक्सिस है, अलोंग द जेड एक्सिस आपका जो एक्सिस पे लाई करेगा मेटल का ऑर्बिटल, दैट इज गोइंग टू बी दिस वन इज योर dz स्क्वायर. ठीक है, लेट मी चेंज द कलर ऑफ द पेन अगेन. अब देखिए यहाँ पे आपके जो अब ऑन द प्लेन आपके जो है अबव द एक्सिस, ऑन द एक्सिस बेसिकली on your x and y axis is going to be present over here dx square minus y square. On the axis they are present. So these are the ligands, these are the orbitals which are present in the direction of incoming ligands. You can see the ligands I have mentioned with red pen, right? So these are already present in the direction of your ligand. So what will happen over here, here will happen your greater repulsion, and greater repulsions will result in your, it will result in your greater splitting. Correct, it will increase in the rise in the energies of these two orbital. Which one orbital, this dx square minus y square, because these two orbitals are present in the direction of your incoming ligand, so इनकी energy increase हो जाएगी. ठीक है, splitting होगी, इनकी energy increase कर जाएगी इन दो orbitals की. So we'll see that. Okay, let me correct it for you. See what I've told you कि जो आपके dx square और dx square minus y square और dz square की जो इन दोनों ऑर्बिटल्स की जो एनर्जी है वो इंक्रीज कर जाएगी, बिकॉज दे आर प्रेजेंट इन द डायरेक्शन ऑफ योर इनकमिंग लिगेंड्स ऑन द एक्सिस ओनली. ठीक है, तो इनकी एनर्जी इंक्रीज कर गई एंड इन दो ऑर्बिटल्स को विल बी डेजिग्नेटेड एज Eg. G इज फॉर योर G stands for your gerate. G stands for your gerate because आपके octahedral complex में there is present center of inversion. You can see center of inversion क्या है, देखिए आपके इस साइड भी ligand present है, यहाँ भी ligand present है, all ligands are present on the all each of these sides. So you can say symmetry is present. You can say center of inversion is present if all the ligands are same. Correct? That is one thing. So that is why we have used G over here. That is gerate. Okay. So the left out orbitals, that is dxy, yz, dxz, they are having greater stability and their energy will be lower down as compared to the rest of the two orbitals, and they will be designated as T2G. Correct? So that is one thing over here. Okay, so proceeding further. So that is your octahedral complex having coordination number 6, and the metal line is at the center of octahedron and ligands are at the corners of octahedron. That is all you know already. Okay, then proceeding further. Okay, that is the structure. I have already discussed that. This one is your x-axis, this one is your y-axis, this one is your z-axis, and the orbitals present in the direction of ligand would be dx square minus y square and dz square in case of your octahedral complex. Okay, so proceeding further, what will happen? This is all your theoretical portion that I have already discussed, and what I have, let's see what they have mentioned. In case of your free metal ion, all the 5 orbitals are degenerate. That we have discussed in your postulates only कि जब भी आपका metal ion जो है वो free state में है, it is in free state, then isolated state में है वो, तब क्या होगा जो आपके 5 d orbital होंगे, they are going to have similar energy, they are degenerate. Okay, same energy होगी उनकी and they are degenerate. Now what will happen? Okay. So if we'll consider the octahedral complex Ml6n positive, जहाँ पे आपका central metal cation है Mn plus, not like this, you can write it like this, Mn plus. Okay, this is how you write it. Is placed at the center of the octahedron and is surrounded by 6 ligands which resides at the 6th corner of your octahedron. अब क्या है, आपने क्या माना कि now suppose both the ligands on each of the 3 axes are allowed to approach toward the metal cation. This is all your theoretical portion जो मैं आपको already समझा चुकी हूँ कि जो आपका metal है, अगर आपकी जो इस तरह से हमने axis draw की थी, x axis, y axis, z axis, और क्या बोला था कि जो आपके metal के dz square z एक्सिस पे जो प्रेजेंट है z एक्सिस के ऊपर जो आपका डी z स्क्वायर ऑर्बिटल है, it is on the direction of your approaching ligand, and the other orbital dx square minus y square is on the direction of your rest of the incoming ligand. So which is why आपकी इन दो orbitals की energy increase कर जाएगी. That is only mentioned over here. So proceeding to our next slide. Okay. सो क्या होगा जब आपके अंडर द इन्फ्लुएंस ऑफ अप्रोचिंग लिगेंड, ये भी मैंने आपको बता दिया था कि जो आपके 5 ऑर्बिटल हैं, 5d ऑर्बिटल्स हैं जो आपके ओरिजिनली डीजनरेट थे फ्री मेटालिक के टाइम में, अब उनकी एनर्जी जो है वो इंक्रीज हो जाएगी. ठीक है, एनर्जी इंक्रीज होगी. ठीक है, फिर क्या होगा, जो आपके T2G लेवल है विच इज ट्रिपली डीजनरेट विच इज ऑफ लोअर एनर्जी, ये सब हम डिस्कस कर चुके हैं. Eg लेवल जो होगा दैट इज अ डबली डीजनरेट विच इज ऑफ हायर एनर्जी. ओके, why doubly degenerate? Because Eg is going to have your two orbitals on the upper side present, that is dx square minus y square and dz square. Okay, so this is how you are going to explain it properly when you are going to attempt your subjective paper. You have to mention A to Z every detail. Okay, so the splitting of degenerate level due to the presence of ligand in a definite geometry is called crystal field splitting, and the energy separation यहाँ पे आप उसको donate करोगे. क्रिस्टल फील्ड स्प्लिटिंग को आप डोनेट करते हो डेल्टा से. इफ यू आर टॉकिंग अबाउट ऑक्टाहेड्रल तो आप सबस्क्रिप्ट में लिख लेंगे ओ. इफ यू आर टॉकिंग अबाउट टेट्राहेड्रल तो आप सबस्क्रिप्ट में क्या लिखेंगे, टी, या फिर कुछ बुक्स में आपके पास इस तरह भी दिया होता है टीईटी, दैट इज फॉर शॉर्ट टर्म फॉर योर टेट्राहेड्रल ओनली. ओके, so so the term 10 dq instead of delta 0 is used. They are trying to say that it is your delta O is equal to your 10 dq only. Okay, so that is one thing. Now another thing is that the energy of 2 Eg orbital will increase by 3 divided by 5 epsilon delta naught, and that of the 3 T2G will decrease by 2 by 5 delta O. Okay, not O, not it is delta O. O stands for octahedral. All right, so that is one thing you can see in the previous slide of yours. Okay, I can show you. So this is over here. You can see that the energy is, to the Eg is increased by 3 by 5. You can also write it as 0.6 delta naught. After solving 3 by 5 you will obtain this, or well you will multiply, as I told you that your delta O is equal to 10 dq. So your 0.6 delta O would be equal to 10 multiplied by 0.6, that is equal to 6 dq. Okay, so you can also write it as 6 dq, and to the below portion you can mention 0.4 dq or 4 dq similarly by multiplying 0.4 with 10. Okay, that is one thing. So proceeding further, what we have discussed till now. Okay, so that is one thing. I hope you have understand that the increase is by 3 by 5 delta naught delta O, and decrease is by 2 by 5 delta O. That is one thing. Proceeding further. So this we have already discussed, that your dz square and dx square is your Eg term would be used for these two orbitals because they are point directly toward the ligands, and there are stronger repulsive interaction with the ligand in these two particular orbitals. Okay, that we have already discussed. And this is another diagram of your metal and approaching ligand they have shown. This is the case of your dz square, another one is the case of your, this is the case of your dz square, this is the case of your dx square minus y square. They have shown the interaction of metal orbital with the ligands only, correct? Proceeding further, yeah, this we have discussed. So crystal field splitting in octahedral complexes, the main diagram that you are going to draw in your paper, in your subjective paper, that is going to be something like this. You can show your d orbital, 5 d orbitals in free ion like this, dxy, yz, xz, x square minus y square and z square. Now, when the average energy of d orbital is present in spherical crystal field, a little bit of energy is increased, but all of their orbitals still, if in their as they are in free ionic state, they will still remain equal, energy will still remain equal. Now when it will increase, when your metal orbitals are present in the direction of incoming ligands. So I told you dx square and minus y square and dz square orbitals are present in the direction of incoming ligand, so their energy is increased like this, represented by Eg, and T to G is decreased, represented like this. Okay, and that I've already discussed with you. This is your complete uh, difference. Energy difference is known as crystal field stabilization energy, that is represented by delta O over here. So that is how you are going to draw your diagram in paper. Okay, continuing further, that is your crystal field splitting that we are going to discuss. So the energy difference between two sets of d orbital that I have told you, T2G and EG, is known as crystal field splitting energy, and it is symbolically represented as delta O, where subscript O stands for your octahedral, that we have already discussed. Delta O is equal to 10 dq, again we have discussed. So the crystal field splitting occurs in such a way that the average energy of d orbital do not change. So when you are going to add your 6 dq plus 4, it is ultimately going to be 10 dq, right? So your average energy is not changing, correct? So this is kind of your very center rule, which is similar to your center of gravity type of rule. Okay, continuing further. So this is your simple description of the same diagram time and again. Okay, so this is also how you can draw. So barycenter or spherical it means the decrease in energy of the set of orbital that lie at the lower energy level. It must be balanced by the corresponding increase in another set. That also we have discussed in previous slides. So now we are going to stop our video over here only because time is exceeded so much. So I'll be stopping it here only. In next video we'll be continuing with our CFSC, that is crystal field stabilization energy for various octahedral complexes. How we are going to calculate CFSC in various octahedral complexes. So thank you.